I'm going to speak about my project. This is which is relevant for clinical and also scientific purposes in the field of epileptic patients. So normally epileptic patients are treated with medicaments and they can be cured in some cases, but in some cases these treatments don't work. So simply there is another option for these patients, which is brain surgery. So brain surgery is only an option if this patient have a localized lesion that causes focal epilepsy. So there are many advanced electrodes that can be implanted in these patients, and normally they have to cover the gray matter. And these electrodes just have two goals. One goal is to capture the signal of the seizures, and the other goal is to capture the signal of most important areas for movement and language, so that the patient is not impaired. So the neurosurgeon, once he has to make surgery on these patients, has to know where the seizure focal start point is, and also where the movement and language areas are. For this reason, we have to localize them. So where are they? So let me tell you why I make a comparison with the Earth and the earthquake and the propagation of the wave in the Earth crust. So imagine that there are many sensors around the Earth, like in California, like in St. Andrews Fault, and there are seismic probes that are able to register the activity of these earthquakes. So in this case, the geologist will measure the activity of each of them, but also as a model of reconstructing the epicenter of the earthquake, and also the location, the entity, how big, how strong is the earthquake. And we can do the same with the brain. So in the case of the geologist, that will tell to the news reporter where the epicenter is and how strong it was, we can also tell where the seizure was, where the language area and the movement areas were, because we can localize them. And how do we localize them? So we also put many seismic probes, many electrodes on top of the gray matter. We localize we make a model of the electric conductivity of the brain, as compared to the geologists that make a model of the mechanical shock waves propagation. Then we measure in many points, then we ask the patient to, for example, speak, to make a cognitive task. So we localize also the cognitive areas to be spared. And then by comparing the model and the recordings, we are able to reconstruct the areas which are relevant for movement, for speech, but also the areas that have to be resected. So the neurosurgeon needs both information. So at the end, the important thing is that we have to ease the recovery of the patient, and then we are helping the patient to come back to his daily life.